we're going to review some keywords to understand the coordinate plane, also called the Cartesian plane. The origin 0, 0 is the point of intersection of the axis. The quadrant is one of the four subdivisions of the plane made by the intersection of the y and the x-axis. Quadrants are read counterclockwise and are usually counted with Roman numerals. The first subdivision will be quadrant 1, the second one quadrant 2, then quadrant 3, and finally quadrant 4. We call that the origin, the intersection of the axis, is 0, 0. Now the x-axis is the horizontal line that contains all the x values, and the y-axis is the vertical line that contains all the y values. The xy coordinate means the x is the horizontal distance and y the vertical distance. The abscissa is any x value or horizontal distance from 0, and the ordinate is any y value or vertical distance from 0. Three, 4 means starting from 0, 3 to the right, and then from 3 you go up 4. Negative 6, 1 means starting from 0 you go left 6 units, and from negative 6 you go up 1. Negative 8, negative 2 means starting from 0 you go left 8 units, negative 8. And from negative 8, you go down 2 units. Negative 8, negative 2. And 2, negative 4 means from 0, you go right 2 units. And then from 2, you go down 4 units. 2, negative 4. Whenever the segments are horizontal or vertical, the length can be obtained by counting. For AB, we count 7 units, horizontal line. For CD, we count 3 units, vertical line. Unfortunately for EF, this counting approach does not work because it's a diagonal segment. What will work for EF is a triangulation. We will create a right triangle with EF, the diagonal, its hypotenuse, and we'll be able to use the Pythagorean Theorem, c squared is equal to a squared plus b squared. C squared will be equal to the altitude counting the units 4 units down, and the base 3 units. C squared is equal to 16 plus 9. C squared is equal to 25, and C is equal to the square root of 25, which is 5. Now, EF is equal to 5. There is an even better technique using a formula This formula only uses the coordinate of E and F, 1, -1, and 4, -4, respectively. And it says that the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. We're going to label the coordinates of E as x1, y1, and the coordinates of F as x2, y2. And our distance will be equal to 4 minus 1 squared plus -5 minus -1 squared. Because we're squaring it, it doesn't matter in which order we pick our x1, y1, and our x2, y2, as long as we are consistent and we keep them in the same position. Now we get square root of 3 squared plus -4 squared, which is square root of 9 plus 16, which is square root of 25, and we get the same answer, which is 5. So that distance is equal to the diagonal. 1 is x1, 0 is y1. Second point, 1 is x2, and 5 is y2. We're going to apply the distance formula, and we realize that 1 minus 1 will be 0. So it's 1 minus 1 squared plus 5 minus 0 squared. So that distance is equal to the square root of 0 squared plus the square root of 5 squared. D is equal to the square root of 25, which is 5. Notice that the x coordinates are the same, therefore it's a vertical line, and 5 minus 0 is 5. The distance is 5. For 3, the distance is equal to -3 minus 1 squared plus 6 minus -2 squared. The distance is equal to square root of -4 squared plus 8 squared. So we're going to have 16 plus 8 squared is 64. So it's going to be equal to the square root of 80. 80 is equal to 16. 16 times 5. So the square root of 80 is square root of 16 times square root of 5, which is 4 square root of 5. So that distance is equal to 4 square root of 5.